Hello, in our lesson today, let us discuss about the famous relation E equal to mc square and the mass energy equivalence. When we go from Newtonian mechanics to relativistic mechanics, many of our ideas need modification. The idea of mass, the idea of length, idea of time, they all change. But what does not change in relativistic mechanics is the definition of work. Definition of work is still integration of force with distance. So if a body is at rest and you push it with a force F, then the work that you do will be its kinetic energy. So this is reassuring that our old idea of work equal to integration F dot ds is still there in the relativistic scenario. So certain things change, but a few things do not change. So let us use our old idea and calculate the kinetic energy of an object of mass m, relativistic mass m. So the force is rate of change of momentum, m into v ds, that is the work that you do on that object which will appear as its kinetic energy. Then what is the kinetic energy of an object in the relativistic mechanics? So the prescription is that it is rate of change of momentum ds integration. ds dt is v, so we write dmvv, then do a integration by parts. So this is first function unchanged integral of the second minus integral of derivative of the first and integral of the second. So let us put this relativistic definition of mass, that is m0 by root over 1 minus v square by c square v dv. You divide it by 2 and multiply by c square. So c square by 2 m0, and in the numerator is 2v dv by c square, and this minus sign can be absorbed inside, so this is now plus. Introduce a new variable 1 minus v square by c square as z, then dz is minus 2v dv by c square. When v equal to 0, z is 1, and when v equal to v, z is 1 minus v square by c square. So limits of integration is 1 to 1 minus v square by c square, and we have rewritten this as m0 c square by 2, m0 c square by 2, and this term is there mv square. So kinetic energy is now mv square plus m0 c square by 2 integration 1 to 1 minus v square by c square dz by root z. So this integration can be done very easily. So mv square plus m0 c square by 2 z to the power half by half. This half is there, so 2 goes upstairs, then this 2 cancels. Then we get mv square plus m0 c square, then putting the limits here, root over 1 minus v square by c square minus 1. So kinetic energy m0 v square by root over 1 minus v square by c square plus the first term is m0 c square root over 1 minus v square by c square minus this is m0 c square. So let us add these two terms, and LCM is root over 1 minus v square by c square, and first term is m0 v square, second term is m0 c square root 1 minus v square by c square multiplied by root 1 minus v square by c square. So root goes, so that means m0 c square 1 minus v square by c square. This term m0 v square cancels with this term, because here c square cancels, so this m0 v square. So this term is cancelled with this term. What remains is m0 c square. So we get m0 c square by root over 1 minus v square by c square minus m0 c square. But this is mass in the theory of relativity m. So that means kinetic energy is m minus m0 multiplied by c square. That means the increase in kinetic energy results in increase of mass. Mass increases, and vice versa. If mass increases, then kinetic energy increases. In the theory of relativity, that is the interpretation. Then we have to interpret this m0 c square also as in the same footing. So energy m0 c square can be interpreted as the energy stored in a body when it is still at rest. So that is its rest energy. So this is important. This is something new. That is the rest energy that we get in the theory of relativity, which is m0 c square. So the total energy is now the rest energy plus kinetic energy. Kinetic energy plus rest energy. Let us define it as E, total energy E. It becomes mc square. So this is our famous equation equal to mc square, which gives the equivalence between mass and energy, discovered by Einstein. This famous relation equal to mc square, discovered by Albert Einstein. Then from this equation we can write m equal to E by c square, or momentum mv is ev by c square. So let us examine this equation. E equal to m0 c square by root over 1 minus v square by c square. Then if we square it, then E square multiplied by 1 minus v square by c square equal to m0 square c to the power 4. That means E square equal to E square v square by c square plus m0 square c to the power 4. So let us multiply it by c square and divide by c square. Then now from this, here you see the momentum is ev by c square. Then E square v square by c to the power 4 is momentum square. So we write E square, this E square equal to c square p square c square plus m0 square c to the power 4. So this is the relativistic energy momentum relation. So from the relativistic energy momentum relation we can see two things. If an object is at rest, that is momentum is 0, then it has the energy which is the rest energy, that is E square equal to m0 square c to the power 4, or E equal to m0 c square, that is the rest energy. On the other hand, if a particle or an object is massless, that is its rest mass is 0, still it can have momentum. So if m0 is 0, then E square equal to p square c square. Because c is constant, that means p is non-vanishing because it has energy. So even a massless object, if it has energy, then it will have momentum. Photon is a massless particle, that means its rest mass is 0, but still it can have momentum. Cooling with lasers, for example, you can use photons, or in optical tweezers you can use momentum of photon. So that is that magic of momentum of a massless particle, and this is the magic of mass energy equivalence. So I hope you have enjoyed this little talk, and thank you for watching.